Welcome again, boys and girls. Again, I'm Miss Williams, first grade math at Minnie Ruffin Elementary. Today, I want to talk to you about Module 6, Topic C, Lesson 10. Let's start with our objectives. It's always important to know what we're going to be learning. Okay, our objective is we're going to add and subtract multiples of 10 from multiples to 10 to 100, including dimes, okay? So as we go back and review Lesson 9, remember, we know that one dime is equal to how many pennies? Not 10. Good. I almost said 9. Thank you. Okay, let's read our learning goal. Remember, this is what we're expected to know when we complete this lesson. I can explain how to find 10 more or 10 less than a two-digit number. Okay? I can explain how to subtract multiples of 10 from other multiples of 10 up to 90. Okay, so I want you to remember those learning goals, because as we get through the lesson, I will reference back just to make sure that we're mastering those goals. Ready? Good job. All right, so first we're going to warm up with an activity called to 10. Okay, get to 10. We're going to get to 10. Okay, so first number I'm going to show you. What is this number? 9. Good. All right, so we have 9 objects. We want to get to 10. What number can we add to 9 to get to that 10? 1. Good job. You're right. We add 1 to 9 and it becomes 10, okay? Let's pick it up a little bit, okay? Let's go to this number. What's that number? 19. Good job. How many do you think 19 needs to get to the next 10? 1? That's it? Let's try something. Let's try the strategy we've learned at the beginning of the year, counting on, just to make sure, okay? What number will we start with? 19. Good job. 19, 20. Oh, awesome. You're correct. It is 1. So 19 plus 1 is 20, okay? This is looking awesome. Okay, let's try another number. What's that number? 79. Good job. How much do you think we're going to have to add to 79 to become 10? Why did you say 1? What did you think about that? Right, because all of these numbers end in a what? 9. They all have a 9 in the ones place. And we know that 9 needs one more to become 10. So let's just count on just to make sure. 79, 80. You're correct. We only needed one more. Okay, so let's move on and let's try numbers with different endings, okay? And we'll go ahead and record on the side that when a number ends in a 9, how many does it need to add to get to the next 10? 1. Good job. You're absolutely right. Just give me a moment to erase. Okay. All right, so let's try another number. What is this number? 5. Good job. How many do we need to add to 5 to become 10? How did you know that answer so fast? This is a what? You're right. This is a double fact. And we know that 5 plus 5 make 10. Good job. Okay, let's try another one. What's this number? 65. Good. How many do you think 65 needs to make the next 10? Let's count on to find out. 65, 66, 67, 68, 69, 70. You're absolutely right. It only needs 5. Why do you think both of these numbers needed 5 to make the next 10? Good job. You're right, because both of them have a 5 in the ones place. And we know that 5 and 5 make what? 10. Good. All right, let's move on and try another set of numbers. I want to see if I can trick you up. Okay. Erasing. So while I'm erasing this, let's review what we've learned so far. When a number ends in 9, we need one more to make the next 10. When a number ends in 5, we need 5 more to make the next 10. We also reviewed that 5 plus 5 was called a double fact. Good job, okay? Next sequence. What is this number, boys and girls? 8. Good job. Now, how many does 8 need to become 10? How did you know 2 so fast? Okay. And how else did you know? I'm loving it, okay? So, we know that 9 needed 1 more to become 10. So, 8 needs 2 more to become 10. Let's just count on to make sure that we're correct, okay? 8, 9, 10. You're right. Needs 2 more. Okay, let's move these numbers up a little bit higher, okay? What's that number? 48. Good job. How many do you think 48 will need to become 10? Good job. Why did you say 2? How did you know? Right. 48 ends with 8, and we know that 8 only needs 2 more to become 10. So 48 also needs 2 more. Let's see what we get when we add 2 to 48. 48, 49, 50. Oh, you're awesome. You rock, okay? Let's try another number at the end, okay? So going back through, we know that 9 needs 1 to become 10. 5 needs 5, sorry, to become 10. 8 needs 2 to become 10. Let's see what this number needs to become 10. Oh. What's this number? 7. Good job. What does 7 need to become 10? 3? You think so? Okay, let's count on and see. 7, 8, 9, 10. You're absolutely right. And we also know that 8 needed 2 to become 10. So if 7 was 1 less, it obviously needed 3. Okay, let's try a bigger number. What's that number? 97. Good job. So what do you think 97 will need to make the next 10? 3. Good job. Okay, let's count on just to make sure we got that correct. 97, 98, 99, 100. You're awesome, okay? Before we move into our concept development, I just want to go over those getting to 10 just to make sure that you understand what each number needs to become 10, okay? This is a very important skill, one of the most important skills to me in my point of view for first grade. So I just want to make sure that you're there. So we're going to start with the number 0. How many does 0 need to become 10? How many fingers are down? 10. Good job. So 0 and 10. How many does 1 need to become 10? 9. Good job. What about 2? Yes, because we said 8 needed 10. So 2 and 8. Good. What about 3? Right, because 7 needed 3 to become 10. What about 4? 6. Good job. And what about 5? Yes, it needs 5, and that is a what? Double spats. Good job. That's called getting to the next 10, okay? Now, we're going to get into our lesson here, okay? Going to record a number sentence. Okay. This reads 4 plus 3 equal, okay? 4 plus 3. Let me draw 1, 2, 3, 4. That's going to represent that number 4. And let me draw 1, 2, 3. That's going to represent the number 3, okay? So, read it with me with the answer, please. Thank you. 4 plus 3 equal 7. Good job. Okay, let's change it up a little bit. Let's add some units on into our numbers, okay? So as I touch them, this time we're going to say bananas, okay? 4 bananas plus 3 bananas equal 7 bananas. Good job. So 4 plus 3 equals 7, okay? So let's take these numbers and let's put them in a number bond. Really quick, let's review what a number bond is. What is a number bond? Yes, a number bond is made of 2 parts that make a whole, okay? So, which one of these numbers is the whole? Yes, 7 is your whole. So, what are your 2 parts that are put together to make that whole? 4 and 3. Good job. This time, let's switch over that unit. Let's add tens to that, okay? 4 tens. And how do we show 4 tens in a picture? Good. We just draw one line, okay? So 1, 2, 3, and 4. Good. Okay. Plus 3 tens. How we show 3 tens in picture? Good. We just draw 3 lines, okay? So 4 tens plus 3 tens equal, what do you think? 7 tens. Good job, okay? Do you think that this number bond is going to be any different than that number bond? No. Why? Why is that? Exactly, because we only changed the units, but the numbers stayed the same, okay? So, in this number sentence, what is your whole? 7 tens. Good job. What are your 2 parts? Good. 4 tens and 7 tens. I'm sorry, 4 tens and 3 tens. Thanks. So, how did knowing 4 plus 3 equals 7 help you to solve 4 tens plus 3 tens? Yes, the numbers never changed. We only changed the units. Good job. Now, let's try to make a number sentence, but this time we're going to pull out the values of these tens, okay? You ready? Let's go. What is the value of 4 tens? Are you sure it's 40? Let's count just to make sure. 10, 20, 30, 40. You're awesome. You're right. It's 40. 4 tens is equal to 40. Okay. What's the value of 3 tens? You sure it's 30? Let's count and make sure. 10, 20, 30. Good. You're absolutely right. You're good at this, okay? All right, so since 4 plus 3 equals 7 and 4 tens plus 3 tens equals 7 tens, what do you think 40 plus 30 will equal? Not 100. That's goofy. You're being funny, okay? Let's try again. Yes, 70. Good job. Because we only changed the units. We did not change the what? The numbers. Do you think that this number bond will look any different from those? Let's see, okay? What's our whole in this number bond? 70. Good. 7 is the what? 70 is the what? Big number, okay? What's our 2 parts? 40 and 30. You all did a great job, but now I'm going to try to trick you. I'm going to switch it up a little bit for you, okay? We're going to try a subtraction problem, okay? So, let's go with 7 minus 4. If we draw a picture for this, do we need to draw 7 things and 4 things? No, because this time we're taking away. We're not adding to. Good job. You're very smart, okay? So we draw the whole first. What is the whole so far that we know? The big number. 7. Good. So 1, 2, 3, 4, 5, 6, and 7. Why did I draw it like that? Yes, because 5 and 2 made 7, okay? So what do we go from here? Yes, we have to X out 4, okay? So 1, 2, 3, and 4. Good job, okay? So let's count to see how many is left over. 1, 2, 3. Good, okay? What do you notice about this problem versus the other problem? Absolutely. The whole is in the front this time, okay? In our addition problem, we have our whole in the back, okay? In our subtraction problem, our whole is in the front, okay? The whole has to come first because you can't take away from a smaller number, okay? So since we're subtracting, do you think that our number bond is going to be different? No, just because the whole has changed positions does not mean it will change positions in our number bond. So where is our whole this time? Absolutely, still 7, okay? And what are our two parts? Good. 4 and 3, okay? Now, let's try it with our units, tens. And then we're going to switch over and we're going to do something called fact family, okay? So, we have 7 tens here minus 4 tens equal, okay? What is 7 tens? Good, just going to draw 7 lines. 1, 2, 3, 4, 5, 6, 7. Do I need to draw 4 tens? No, because we're taking away. Good job. So we're just going to X out 4 tens. 1, 2, 3, 4. How many tens do you have left? Yes, 3 tens. Good job. Okay, so our number bond stays the same. We have 7 tens for our whole, 4 tens for our parts, and 3 tens. Okay, now I want to throw a monkey wrench in there. I want to take these numbers and I want to switch them up, and I want you to do an addition problem for me this time. Okay. What will I do? Will I put one of my parts with my whole or both of my parts together? What will I do? Absolutely. I will put both parts together because a part and a part makes a what? A whole. Okay, good. But this time, I want to try values, okay? So, what is the value of 4 tens? 40, good. What is the value of 3 tens? 30, awesome, okay? So, 4 plus 3. Could we solve 40 plus 30 by saying 4 plus 3? Yes, we're just changing the unit. So, 40 plus 30 is 70. Good job. How did you know that? 70 was our whole. Good job. Now see if these numbers change. We put them on the number bond. What is the whole again? 70. Good. And what are your two parts? 40 and 30. Okay, you all did a great job today. And just going back through what we've learned for this lesson. Smaller numbers can help us solve bigger numbers. The only difference we did was we changed the units at the end of the numbers. But knowing these simple facts can also help us solve bigger numbers. Thank you for joining me, and I'll see you next time.